This is a brief introduction on what quadratic expressions are. So a quadratic expression is an expression where the biggest exponent is 2, an x squared term. All quadratic expressions can be written like the one on the right, a times x squared plus b times x plus c, where a is the quadratic coefficient, which is why it's with the x squared, where b is a linear coefficient, which is why it's with the x, and c is the constant, so it's by itself. We've been dealing with quadratic expressions with the equations we have been solving on live day 1, but none of the expressions have had a linear term, so none of them have had the x in it. So why does it matter? So if we look at this expression right here, this equation of x squared plus 5x minus 3 equals 2, we may have begun by trying to get the quadratic term by itself so we could square both sides. So if we add 3 to both sides, we can cancel out the negative 3 and we get x squared plus 5x equals 5. And then if we try to get the x squared by itself by subtracting 5x, we'll notice that yes, we have the x squared by itself, but we can't square root 5 minus 5x. Whereas in lab day 1, anytime we moved everything to the right side, we were left with x squared equals a number, but that's not the case anymore. So a quadratic equation, like we talked about in the first slide, is a times x squared plus bx plus c equals c. And the most important part of it is the fact that it needs to be equal to 0. Once an equation is in the form above, meaning it's equal to 0, with ax squared plus bx plus c, we can solve all quadratic equations using the quadratic formula below. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That's the quadratic formula. And we use the a, b, and c values from our quadratic expression in our equation to plug into the quadratic formula. So let's take a quick look here. Rewrite the equation in standard form. For it to be in standard form, that means I need all my x squared terms to be by itself. So I would first need to subtract x squared. So if I subtract x squared, my 3x squared is going to become a 2x squared. I'm still not ready yet because I still have a 3x on the right-hand side and I need that to be a 0. So I'm going to subtract 3x from both sides, which then gives me the 0 I want. And I can now simplify negative 5x minus 3x to be 8x. So now I'm ready to identify a, b, and c. So a comes from the x squared term, so a equals 2. A isn't the entire thing. A is just the number out in front. So not 2x squared, it's just 2. So b is going to be negative 8, and c is going to be 4. So here's just a list of some common mistakes to look out for with the quadratic formula. The first one being that the division bar extends all the way for the numerator, so it includes the negative b plus or minus the square root of b squared minus 4ac. Okay, that's all included. Negative b is the opposite of b. So if we look at this first part, it says negative b. Well, if b is 4, that means negative b is negative 4. If b is negative 9, then I need to be putting in a positive 9 into my formula right here because the negative is just going to flip it. And then make sure you use parentheses. If you just do negative 4 squared, like right here, you're going to get a negative 16 in the calculator. You have to make sure you put parentheses so it knows that it's squaring the negative 4 and then not just the 4 and adding the negative. Go ahead and try your calculator and you'll see that you'll get the 1 with the positive, 1 with the negative. So that's an introduction. You can go ahead and dive into the rest of the work for Wednesday.